Hi, everybody, and welcome back to Chee-Tash. My name is Chris, and today we're going to be talking about the book Clean Code by Robert C. Martin. Today, talking about Chapter 10 classes. If you guys remember last time, it was all about unit tests and the importance of unit tests, why we write unit tests, and the importance of keeping your unit tests clean so that you can also keep your code, your production code, the design and the architecture of that clean as well. But today we're going to talk about classes. So some object-oriented principles. You guys know mainly I work in Java. That's what I just, in my career in this field, that's what I've always worked in. So kind of applicable. I learned a lot from this chapter, and I hope you guys do too. We're going to jump right into it with the first slide. And Uncle Bob starts out with the first slide, the first section, class organization. So he lists out classes should begin with a list of variables. Within those list of variables, anything that's a public static constant should come first. Then next should be private static variables. Then after that should be private instance variables. And then he writes this note here that public variables really need a good reason. And this kind of is a callback to the chapter where we talked about data structures and objects. And it kind of feeds into this OCP, the open and close principle, where classes should be open for extension but closed for modification. And if you guys remember from data structures and objects, we talked about how you shouldn't have access to an object's inner workings. And by having public variables, that's kind of what you're doing. And getters and setters kind of do the same exact sort of thing. So if you're going to have public variables, this is all in all that to say Uncle Bob is just saying public variables, try not to use them unless you have a super, super good reason to. But this should be the flow of the class. And as far as how your variables show up in the class, after that should be functions. Public functions should follow. Utility functions should be right under the function that is being called in. We learned this way back earlier in the book, actually, was it functions? Yeah, I think the chapter on functions, where if you have a helper function, so to speak, where it's being used in the main function, it should appear underneath. And this is a question maybe other people can help me answer, is because Uncle Bob specifically says right under the function that's calling it. Now, what I've done in my experience is any helper functions, utility functions, are like at the very bottom of the file. So they're underneath it, they're just not right underneath it. So I don't know if that's just a semantics or that's up to you and your team how you want to structure your code, but just a question out there for you guys. And then next, encapsulation. Encapsulation, so in the bullet point there, you can mark tests as protected in order to still run tests on them. So if you guys don't know what I mean by this, if methods are private, you can't write tests for those. Because think about what a private variable is. Private variable is only accessible to other files, classes within that package. When you go to write a unit test for that, you're not going to have access to that method. So if you mark it protected, though, you can still run the tests on them. And encapsulation is one of like the principles of OOP. So you keep everything encapsulated. What does that mean? That means you keep everything within that file so that nothing else is able to, kind of going again back to open and closed, you shouldn't have access to modify or change or know the inner workings of that. It's all encapsulated within that class itself. But continuing forward, classes, all in all, classes should be small. says Uncle Bob. So classes should be smaller, but then they should be even smaller than that, is what he says. I forget the exact phrase. The first rule of classes is that they should be small. The second rule of classes is that they should be smaller than that. So they should be small. They should be small. And the nice thing, I've been finding this out a lot at work, especially with Spring Boot, that you can annotate classes and you can have stuff like getters and setters, constructors, builders annotated at the top of your class so that you don't have to write out all those getters and setters and the multiple argument constructors and what have you. And it's really nice. It keeps your classes pretty small. You can't use that every single. There's going to be cases where you shouldn't rely on that, but for a lot of cases, you can just use those annotations that Spring Boot finds if you guys use Spring Boot. Functions, we measure. What did I mean by that? Functions we measured in lines. No, we're not going to repeat the same exact text from the functions chapter, but as with functions, smaller is the primary rule. When it comes to designing classes, as with functions, our immediate question is always how small. Oh, I got you. Okay. So this section is defined by the size of your classes. How small should your classes be? They should be smaller than that. But in functions, we did say that functions should be small, concise, clean, right? But now that was measured in terms of lines. So functions shouldn't exceed like 100 lines or, something like that. But for classes, we measure the smallness and the size of it based on responsibilities. And we're going to get to what exactly a responsibility is. Going forward on that, the name of a class should illustrate what responsibilities it fulfills. So basically, the amount of things that the class is doing is what a responsibility is. And we found this out too, again, going back to the functions chapter. Your functions should really only do one thing. We also learned about this in the unit test chapter. Unit tests should only test for one thing. They shouldn't test, the processing and then the printing and the labeling. Split those up into different functions, split those up into different unit tests. Classes should be concise. They should have a concise name. If you can't give it a concise name, it's likely too large. And if it's too large, it might mean that it has way too many, you guessed it, responsibilities. So all that to say, there's this principle. We talked about the OCP, the open and close principle, but there's also this single responsibility principle. And as the name kind of suggests, the single responsibility principle states that a class should only have one reason to change, aka it should only have one responsibility, aka it should really only do one thing. So the single responsibility principle is one of the founding principles. I believe it's called SOLID. It's an abbreviation, or not an abbreviation, or yeah, an abbreviation for design principles in software development. The S stands for single responsibility. I forget what the O, the L, and the I and the D stand for, so I apologize, guys. But it's one of the founding principles of SOLID. It's the S part. But even though it's one of these very important principles, it's often misused quite a bit, says Uncle Bob. And it kind of makes sense why it's misused, because oftentimes as developers, we just want to get things working. And as Uncle Bob states, clean code and working code could be two entirely different things. They could look way different. Because I could show you some code that I had that was working, but it was not very clean. But oftentimes, if you write clean code, it will often work. And it's going to be better organized and have more readability, cause less confusion. So it's often perhaps maybe our responsibility, no pun intended there, to to write this clean code, or rather, not responsibility. The blame is often on us for just trying to get code working versus adhering to these clean code principles. Going along with that, I mean, once we get code to work, we often think that our job is done at that point. And also, another reason why SRP is kind of misused is that when you have SRP, when you're using single responsibility, you're going to often have more classes because now you're breaking up your classes into individual responsibilities. So they should only have one reason to change, right? And you're going to have more classes. You're going to have less classes doing multiple things. And oftentimes maybe people think that, oh, the more classes I have, the more files I have in a project, it could make things maybe a little more confusing, harder to find, etc. But in reality, that's kind of the opposite, right, guys? I mean, if you have classes that are well named and only do one thing, I feel like it's not going to cause confusion. It's going to give more clarity. And yeah, you might have more files, but when you understand what those files do, you can get past the size or the quantity of files that you have. So that's single responsibility. And then on this page or on this slide, I have kind of an example of this. Example of single responsibility. So on the left, this is not adhering to SRP. You have a user class with private instance variables, but look at what it's doing. It's got some methods that are part of the class that are saving a user, they're generating a report for the user, they're sending an email for the user. And you could say that this class might be doing a little too much. So on the right-hand side, this kind of more so adheres to single responsibility principle, where the user class, all its job is to do is just save to a database. If you want to report, you utilize the user report generator class. If you want to send a user an email, you utilize the email service class. And you can see now how better organized this is, and everything's just not quite tied all together in the user class. And also just think about this, guys, on the right. You would probably have these, like this is just from ChatGPT, an example that it printed out. You could have these in different files. So it makes it seem like this is all one file, but you would have these in your different .java files. So I contend what Uncle Bob is kind of saying is on the right, this is better organized. This is adhering to single responsibility. Each class only has one reason to change, or as I kind of like to say, each class only has one responsibility. So next slide, we talk about cohesion. So what is cohesion? Cohesion is how much your instance variables are tied to the methods of your class. So as Uncle Bob states, classes should have a small number of instance variables, and then each of the methods of a class should manipulate one or more of those variables. And this is him writing this. In general, the more variables a method manipulates, the more cohesive that method is to its class. So think about it. It's tightly, instead of calling this cohesive, we can use another word that Uncle Bob used earlier on in the book. I believe we used it before, which is coupled, tightly coupled. So when you have more variables, the more variables a method manipulates, the more cohesive it is to that class. You would think that maybe, okay, it's very cohesive. This is a pretty good thing. But what if that method has to change? What if you have instance variables that change? Now all of a sudden you have to do some more adjustments downstream from that change. You have to then change that method completely, then you have to change that method wherever it's being used in your production code. So Uncle Bob writes that it's not advisable to create maximally cohesive classes. Maximal means that each variable is used by each method. Strong cohesion is a good thing, but maximally cohesive is not the greatest thing. The logic should be coupled, but you should be kind of cognizant of any sort of future changes that might happen and realize how much not leeway, but how much legwork you're going to need to then change everything else from a small change within that class if it is very maximally cohesive. And I'm just trying to make sure here logic is coupled. Okay. Never mind. I was trying to figure out what I meant by that last bullet point. Logic is coupled, but yeah, I think all I meant by that was when you have strong cohesion, the logic is coupled too. So your variables are coupled to your methods. And all in all, the logic of that class is tightly coupled. And then that last bullet point. If things are not cohesive, you can often abstract things out to another class. So if you have methods that are not dependent on any instance variables of that class, well, think about it. That probably means that your class is doing too much, so it has too many responsibilities. You can move that method into another class. And I think I have an example of this on the next slide. Yes, I do. Okay, so here we have a rectangle class, right? We have this rectangle class. It's got width and height. And look at each of those methods. This is actually a pretty cohesive class. And I'm saying that because, as I get some hair from out of my face, this is a pretty cohesive class because each of those instance variables is used within not every method, but almost all the methods. So it makes sense that the getters are only getting their specific instance variables. Get width is returning the width. Get height is only returning the height, etc. But down there, you can see the area, the perimeter, the square. Those are utilizing all the instance variables. So I would say that this is a pretty cohesive class, and it would be hard to abstract anything out into its own separate class here. This is pretty strong cohesion, I would say. Next slide. Maintaining cohesion results in many, many small classes, and this is true. This is what we were saying before when we said that when you have a method that is not utilizing any instance variables, then you can abstract that out into another class, and you could potentially have many, many different classes that all do one thing. They all serve one responsibility. And as Uncle Bob says here, when classes lose cohesion, split them up. So if here, for example, on the left, we have this calculator class, right? We have this calculator class, and it's got this divide method. Now imagine maybe the divide method here is not utilizing any of the instance variables in the calculator class. Well, instead of having a divide method in the calculator, why not just make a divider class and have the divide method in there? In that way, calculator can kind of use divider as maybe an instance variable. They could have a private divider or private instance variable of a divider type, right? And as Uncle Bob says here, oftentimes this may result in larger classes and more code, which again is one of the reasons why SRP is often broken, because we often think and equate, oh, more code, more complicated. But I don't think that's the case, especially if you name your classes correctly, you follow clean code principles, and your classes just do one thing. So all in all, to say, if there's not a lot of cohesion in your class, find the methods that are not cohesive with your instance variables, split them up into their own separate class. Next up, organizing for change. So we talked about this earlier in the video, about the open and closed principle. So classes should be open for extension but closed for modification, right? So we want to structure our classes so that we can potentially update them later. So this is what was kind of done in this example. This is a classic example that I've seen a lot, and this is, again, from ChatGPT. Instead of making a rectangle class with this getArea method, right? Why not create a shape class, abstract the class into a parent that houses all the methods that you're going to need? So that way, it's open for extension, and that way you don't have to modify every single shape class. You don't have to, if you had a, here I have a rectangle, but if you had a circle, triangle, trapezoid class, if any sort of change happened to this getArea method, you would have to change it in every single one of those classes. Potentially, right? But when you override the getArea method from shape, and you can do that because rectangle is extending shape, that means it has access to its methods, then if something happens to the area of rectangle, if all of a sudden the calculation changes, you just change it right here. You don't have to change it in every single one because it's inheriting it from shape, and shape is telling you, hey, yeah, you can use this getArea, use it however you want. So Uncle Bob is saying here to kind of get out in front of changes. Get out in front of your code and see where you're able to have modification, and see where you're able to have extension, or where you shouldn't have modification and where you want to open things up for extension. Because ultimately, I guess the best way to put this is get out in front of the fact that maybe later you're going to need updates, and you want to make updates in the most efficient way possible. And you don't want to have to update tons and tons of places in your code. And you can do this by following, single responsibility. You can do this by following the open-close principle. And then lastly, isolating from change. So organizing from change, isolating from change. So there's those abstract classes which are open for extension, but there's concrete classes. So concrete classes are just classes where they contain implementation details. And that's really it. Think about concrete, like something that's frozen in time, or something that is not going to change, right? So all this class would do is just, hey, it's just going to contain implementation details. It's not going to do much else besides just provide a visual representation of, or provide you a representation of some sort of data. That's all it's going to do. That's at least that's what I kind of think about. So concrete classes maybe have some advantages, but one of their disadvantages is that depending, let me see how Uncle Bob wrote it here. A client class, depending upon concrete details, is at risk when those details change. Right. So he says we can introduce interfaces, abstract classes to help isolate the impact of those details. Right. So think about it. Concrete class, right? You're expecting it not to change. That I know earlier I said it's something that's concrete. It's going to be frozen in time, right? But let's say something does change. And then all of a sudden, any class that was using the concrete class, all of a sudden those got to change too. So there's ways around that. There's ways where you can create abstract classes and interfaces and then allow for other classes to implement or extend those classes and utilize the methods in their own fashion that they want to. They can override those methods and provide their own implementation for them. Just like you saw in the previous example with get area. Because the area is going to be different for every shape. So we can better organize our code by saying, hey, shape interface is going to provide you with the method, and then you do with it as you will. Another thing about concrete classes is that they make testing difficult because of the volatility of if things change. So you write tests, based on your production code, based on these concrete classes that you have, but all of a sudden if things change, unit tests break, which I guess is in one way is a good thing because then it shows you, oh, okay, I got to update these tests, right? The code, something changed in the code when I pulled down the new repo. Hopefully they're updating the tests with it, but you guys know what I mean. So when those concrete details change, well, potentially some unit tests are going to have to change. So makes testing a little bit more difficult. So there's this concept that Uncle Bob talks about, which is dependency inversion. And this is kind of how to mitigate any sort of issues with concrete classes, in that classes should depend upon abstractions and not on concrete details. So exactly what we were talking about before. My rectangle class should depend upon the abstraction, which is shape. It shouldn't have to depend on, the details provided by the rectangle class itself. It shouldn't provide its own get area method or calculate area method. It's going to depend on the calculate area method being in the shape class. So I know we've used like a lot of different terms in this chapter: single responsibility, open closed principle, dependency inversion. And the best way to remember dependency inversion DI is classes should depend on abstractions. It's going to make testing perhaps a little bit easier than relying on those concrete classes, and especially when things change and the methods and the concrete details need to change later. Well, when you depend on the abstractions, it's going to be easier to make those changes. So this is kind of an example that he used in the book, but I'll just read it. I'm not going to give a lot of context to it, but you guys can fill in the blank and utilize other examples than the one he's using here, because he's talking about this concept, and he's talking about making like a portfolio class. You've got a Tokyo Stock Exchange class, a stock exchange interface, right? So instead of being dependent upon the implementation details of the Tokyo Stock Exchange class, our portfolio class is now dependent upon the stock exchange interface. The stock exchange interface represents the abstract concept of asking for the current price of a symbol. This abstraction isolates all of the specific details of obtaining such a price, including from where that price is obtained. So you could, fill in the blank there. Instead of being dependent on implementation details of the rectangle class, our shape class is now dependent upon, or excuse me, our rectangle class is now dependent upon the shape interface. So maybe the puzzle class, instead of being dependent upon the implementation details of the puzzle class, our rectangle class is now dependent upon the shape interface, something like that. But you kind of get the picture there. And all that to say, guys, that's going to do it. That's going to do it for Chapter 10 on classes. Hopefully you guys learned something. Learn something about single responsibility. Learn something about how big classes should be. Learn something about the open and closed principle and why that's important, and even dependency inversion. So, guys, thank you very much for listening. My name is Chris. Tune in next time. I don't know if there'll be an episode next week, but definitely the week after that. Tune into the Chee-Tash podcast. We just had a full interview drop with Patty Smith. She's an author, wrote a book about beer. That was a cool conversation. I'm not a beer person. I don't really drink as it is, but that was a fun conversation, just learning more about beers. And guys, thank you very much. Tune in next time. My name is Chris. This has been Chee-Tash. Take care, everybody.